Hello, everyone. Happy to bring another episode to you on the podcast. This time, Rafael Tudela, a newbie Tapecon employee, but under 2 years old at the company. Really happy to have him on. He's the second employee that we've had on the podcast. But with his electronics, electrical engineering background, he shares a lot of insights of traditional electronics versus his experiences as working on projects for us in flexible hybrid electronics. We talk about demonstrators and the value to create validated reference designs to short circuit the speed to market of new products, and just some educational insights of Rafael's journey from, I'll say, the educational world into the industrial world, and some of his experiences through that journey, and curriculum and some different things on the electronic side. So hope you enjoy. Without further ado, bringing you Rafael, a Tapeconian, here into the podcast. Thanks. Welcome, everyone, to another episode of the Better Product Solutions podcast. Excited to have Tapeconian number 2 in the podcast. So if you remember in a previous podcast, if you listened to it, we had Dave Shoemaker, who was, like a 35 plus year tenured employee at Tapecon. And this time I'm really happy to be inviting Rafael Tudela on the podcast, who I'll let him kind of give his own intro, but I would say he's more on the spring chicken side of the business, under 2 years old at Tapecon, but with his background, really excited to have him on our team, and wanted to bring him on to talk about some really cool things in flexible hybrid electronics, some different things that he's been working on. So, Rafael, welcome to the
Yeah.
podcast. And I'll put you right on the spot, Rafael. And you've jumped right into our organization, doing some really cool things. But your background is really cool. So, if you could tell us about yourself, your role at Tapecon, and your official title, applications engineer. But I feel like you're wearing a lot of different hats right now. So, welcome to the podcast.
Yeah, thanks for having me. Yeah, my background's in electrical and electronics engineering. I spent my short-lived career mainly on the electrical side, and now have hopped back over to the electronic side. And the difference between that being electrical is more dealing with the bigger power, whereas electronics are dealing with the smaller components and smaller power. So glad to be on board. Definitely learning a lot more new things, and enjoy doing it. As an applications engineer, I handle a lot of the customer designs, but also I'm kind of one foot in the R&D aspect of it as well.
I think you get to claim the first employee hired like completely virtually, because we started doing virtual
Right.
interviews and everything like that. I remember it was like all on Microsoft Teams at that time, because it was like in the heap of all the COVID stuff. So congratulations on having that, I guess, feather in your cap of the first virtual employee. But you didn't mention your double major, and I remember with your background being both electrical and electronics, maybe you did mention it, but can you highlight that a little bit? I mean, why did you pick, why two? Why a double major of electrical and electronics? I'm not complaining because I love the background.
Yeah. So with any sort of engineering, you got pretty much a broad landscape, and you can land on your feet anywhere. So I've always been interested in tinkering with things, and electricity's always seemed like a magic smoke to me. So I chose electrical and electronics engineering. One, for job security. I feel like I don't have to worry about that end of things, and also the different avenues you can go. You're not set into one direction. And as clearly shown here, is I coming from electrical background and then coming into electronics.
Yeah, and we're going to talk all things electronics, but so you've been introduced, coming into our organization. Obviously, we've been doing what I'll say is core printed electronics work for a lot of time, for a long time, in terms of our memory switch keypad, user interface stuff. But we've kind of thrown you into the mix of really being charged with this flexible hybrid electronics category, and challenging some of our current capability, and translating some things. So can you talk about some projects that you've been currently working on related to, not only just the regular, I'll say, printed electronics, but also the flexible hybrid electronic side, or maybe even talk about the difference?
Yeah, for sure. So just to give a general definition, flexible hybrid electronics, I'll say it as FHE, is a combination of printed flexible circuit with hard state components on it. So technically, Tapecon has been making FHE since the 90s, with our membrane switch keypads. But I would classify those as almost on the lighter side of the FHE because they have resistors, buttons, and LEDs, whereas the FHE that we look at today are housing IC chips as well and capacitors and transistors. With the Tapecon core business, our main focus is membrane switch, which is a printed circuit with buttons and LEDs. But our newer development that we're looking at is going to be a much more advanced version, be able to be like a self-sustaining device or a sensor of sorts. So it's really exciting stuff there. One of the projects we're working on is a stick-to-skin temperature sensor, which is going to be completely wireless, and tell either a data pool or an individual their temperature.
Yeah, and I'm glad that you said self-sustaining because I know I mentioned to you how I was at that innovation summit in New York State, a few weeks back in November, and I was at that in a panel about flexible hybrid electronics, and talking about and one of the points in the panel was about how Moore's law, which to, I'm gonna probably say this wrong, but semiconductor chips, just completely like doubling in computing power in this Moore's law that kept, doubling and doubling, doubling, but they're now starting to feel like it's slowing down. And so this whole chip capacity being now people were talking about this concept of make sure I get this right, distributed computing. And so when you say self-sustaining, it just makes me go back to that comment where I'm just excited how the opportunity to build smarter, flexible hybrid electronics that have, I'll say, that can supplement the computing power limitations in the ceiling that people are running up against with just the microchip itself and relying on one entity. Sorry if I stole some of your thunder there,
No,
but
that's
a question on additive versus subtractive manufacturing, and I joke because when we give student tours in here, I joke and say we've been 3D printing since 1919 because we've been, you know, printing for a long time. But how do you see the difference, in terms of do you consider yourself like I've entered a company, I'm now an additive printer, but then that's one thing. But then you having an electronics background coming from school, there's the whole additive versus subtractive processing in traditional rigid circuit boards. Can you speak about where you see the difference and what the pros and cons are?
Yeah. So in schooling wise, the only additive manufacturing processes that we had available to us were 3D printing. So that'd be just your classic PLA plastics or ABS plastics, nothing to do with conductives or graphics or anything. So when we were building circuit boards in school, we're using the traditional redactive or reductive process to etch away the the layers until you have the copper traces and whatnot. When it comes to doing additive versus subtractive manufacturing, there's two big things involved. So one is the cost. Instead of a customer paying for an entire block of copper that's going to be etched away, they're now only paying for the amount of what we traditionally use as silver traces. So that's the big thing, a big draw for customers is it's a lot cheaper than you would of a traditional board of the same size. And the other thing is sustainability. So I also come from almost a certificate in sustainability side of things where we got one world and it's not going anywhere. So to be more sustainable is a big draw, and that's what drew a big draw for me to come to Tapecon was their awards in sustainability. So with this, again, we're not using harmful chemicals to create the circuit, which is why most of our circuit boards are overseas because of the strict EHS guidelines that we have here. Some of those chemicals can't follow that. And then as well as the waste is a lot less because you're not taking away, you're adding to it.
Yeah, I like to think also that because we're additively printing on, you know, a portfolio of films, right? There's innovation in the, you know, casting of those films, or I should say just the creation of those films that can introduce properties that I don't know, it can be a little bit more innovative in a solution as opposed to maybe a one size fits all FR4 board. And I've always heard FR4, but I don't even know what FR4 board is. I don't know what it actually means, like what the F and the R stands for. I just think FR4 board. But it always seems like the same base material for a rigid circuit board. Am I simplifying that too much, or is that
No,
kind of
no, that's right. The different letters and numbers just mean thicknesses or how many layers are on there. So FR4 board's pretty standard across the industry for
yeah, but it's
small
different
circuit.
than maybe thinking about, the various polymer attributes that could be in a film that could then contribute to the overall performance of
Yeah,
that additive process, right? Whereas it
right.
seems like with that FR4 type, you have restrictions, or maybe there's just a set number of choices, and then that's kind of it.
Right, right. And when you're talking like FR4 or PCB, you're limited to whatever you make it on. Whereas with the additive process and the substrates, you can add another substrate. You can put adhesive on the back. You can have substrates that are dielectric on their own. You could have all these different capabilities and just by adding a thin layer of film
Mhm.
or printing right onto that layer.
No, for sure. It's almost like, well, I'm going to move into this question on demonstrators because when you have all this, I guess we can replicate and we can make samples. You said you're working on, the one stick to skin sensor project, and ultimately, you're learning all about, I'll say the technical challenges to translate a rigid design into a flex type design. But at some point, creating a demonstrator really can be beneficial. And I guess you're right in the center of creating a demonstrator that could be used to, showcase, I'll say, the technical feasibility of the technology. Where do you see, I guess, the value of a demonstrator, and what's the benefit of having it, and what's is it worth the effort, creating the demonstrator if you know that we might not, be selling that demonstrator, but it's more of just kind of like a sales sample or sales demonstration?
Yeah. So I've been saying that a picture's worth 1,000 words, a demonstrator's worth a million. Because if you can put something in the hand of a customer that works, as it's essentially almost a glorified prototype that's not for sale, then they can see the functionality, they can see what it looks like, they can compare it to what they currently have. If they may not even realize that they needed something like this or even thought of this as an avenue. Most if you're not in the electronics realm, you'd think that all circuits are on one hard piece of plastic versus being able to have flexible circuits like this. And I'll mention, like, in schooling, all we did was on hard PCBs. There wasn't anything directed toward FHE. Maybe if you were going for your doctorate in highly specific field there, but you don't know what FHE is. And I think that by producing these demonstrators, not only FHE but other membrane switches and whatnot, that you realize that there's valuable and really really good pieces of information on it that you might not have realized that was there. For instance, just in house, we're redesigning a tape dispenser for one of our brands that we have. And originally, it's got all these components. It's got what's called a 7-segment display, which is a series of LEDs, kind of like your old-fashioned alarm clock. And then it's got some push buttons. And then it's got to be cut out of the stainless steel that the tape dispenser is made out of. Well, now we're looking at it like we're making membrane switches here, so why not make a membrane switch for that? Which, one, we're paying for every cut that we make on that stainless steel, and then also the components that are added to it. So we can now, within the faceplate of it, we can put the circuit for it, reducing cost and being more sustainable.
And it's not like you're making these demonstrators in a black box and not documenting anything. Like, I mean, my impression is that, you've got engineering drawings behind everything. You're doing performance testing on the demonstrator. So it's, we benefit from getting some know-how from the demonstrator itself and start to publish that data. One of the concepts that I saw on a contract manufacturer's website was this concept of validated reference designs, where you can have, a set of designs that we've kind of internally advanced those designs and have, the design, some of the performance criteria, and then if a brand owner wanted to say, "Hey, wow, we want something that's really close to that," and we're like, "Okay, well, take this validated reference design. You just skipped steps 1, 2, 3, and now you're starting at step 4 instead of step 1." Is that, is that fair to say that we're advancing, creation of a concept of a validated reference design while we're creating demonstrators?
For sure. So the example I gave earlier of that stick to skin Bluetooth thing, it's kind of like that. We have the design around the Bluetooth sensor, and then we have an input output that's going right now to a temperature sensor.
Yeah.
But swap X with your technology, and then you have a whole new sensor that's Bluetooth enabled. Or, for instance, other versions of that. We could do whatever type of sensor, whatever type of communication method. And once you have one, it's almost a one for one switch. Of course, it's not that simple, but you already have the baseline ready to go.
Yep. Yeah, so we're learning as we go, but then I guess teeing up someone to take advantage of of what we learned.
Right.
So I'm shifting gears now because you mentioned, you've mentioned schooling a couple times, what you did or did not learn, in school. And so the question of, just how does that and plus, of course, workforce right now is all the rage in terms of challenge and stuff. Um, where do you see, I guess, the role of the education that you had with a double E, plus plus major coming into TapeCon? Where do you see that, I guess, that impact when you joined TapeCon? How did you feel the impact, or what have you thought about since with regards to your education?
Yeah. So it's when it comes to FHE, it's really a pioneer's game right now. Everyone's racing to become a manufacturer of FHE. So really, there's not much academics behind it. But I will say, that um, the schooling I had definitely helps in the long run, especially when it comes to design work or understanding how something is or how something works, determining what kind of sensor we want to use, analog, digital. It helps that way. But really, you see businesses driving this FHE knowledge because it's a pioneer's game, because there's not much out there on it. So we're in the process of learning it. Everyone else around us is learning it, but really industry is driving it.
Yeah, I mean, this is the importance of those trade associations. On episode 1 of this podcast, we had Len Allison on, and he was really big on standards, some of the standards committees, ASTM for membrane switch. And it's like that was when a membrane switch was in its early infancy, right? And I think we're right there again in some aspects. So obviously, your opportunity as an employee at TapeCon, of course, is to start getting involved in some of these associations, because it does seem like if it's not going to be trailblazed at the academic level, at least in for the type of degree that you graduated with, it's kind of specialty or not, maybe not justified in a particular curriculum. It's going to have to come out in these industry trade associations, all the collaboration amongst and the co-opetition in the industry. Is that, I guess I'm soapboxing, but do you agree with that?
Yeah, I agree. And and it's really cool too, especially just speaking on behalf of TapeCon, that the additive manufacturing and additive printing is really taking a stake in the electronics. So it's not no longer just these electronic manufacturers. It's also guys like us who are printing, and then we can even further advance the technology of saying what components can we print with it instead
Mhm.
of can I just do the traces, can I actually print some components?
Well, yeah, especially when you're hearing about all the supply chain shortages in this industry or the traditional component industry. It's like make versus buy. I think a lot of people would figure out, hey, how can we make? And
Right.
additives right there. The challenge is right there, right? To go out and try to solve that challenge. Well, I mean, that's all I had, Raphael. And I, obviously, really happy to have you, on the team and involved in all these projects and kind of on the bleeding edge of this stuff. And thanks for coming on and kind of sharing your perspective on it. Is there anything that, you want to say or close with, or anything to wrap up on the podcast?
Yeah, well, first, I appreciate you having me on here. I'm excited for the way forward. I think it's going to be a really big market driver is going to be FHE and stick to skin, or distributed computing, as you mentioned. It's where we're going, and Tapecon's willing to do some investment in that journey. And I think good things are to come from it. So I
All right.
appreciate you for
I like
bringing
that.
me up on board.
All right. I like that conclusion. It's good stuff. All right. Well, hey, thanks, Rafael. And I'll see you sometime very soon because we work at the same place.
All right.
All right.
Yeah.
Thanks.
Thanks for having me.
All right. The Better Products Podcast is about educating product teams about new materials and new technologies, all in the custom material converting and printed electronic space to help them design and build better products. So in this podcast, I'm hoping to get wide-ranging conversations with various people throughout the industry and just bring a lot of good content to the table. So if you're interested in learning more about the industry, materials, processes, how to improve products if you're on a product team, or just general know-how of what the heck is going on in this industry, then subscribe to the podcast and get ready for some more really good episodes as I bring in some great guests. Thanks.